Getting the Cauchy Riemann equations in polar coordinates, that if I take a point, then writing the Cartesian coordinates of that point to be x, y, and the polar coordinates of the point be r, theta, right? Now writing x, y in polar coordinates, so for that we write x to be as r cos of theta and y to be r sine of theta. We know that z is x plus iota y, putting the values of x and y over here. So this is r cos of theta plus iota, r sine of theta. Taking r common, we get r cos of theta plus iota sine of theta. And by Euler's formula, this is equal to r into, this is nothing but e the power iota theta. So this is e the power iota theta. So z is equal to r e the power iota theta. So what will be f of z? This is f of r e the power iota theta. Very fine. And we also know that this f of z is u plus iota v. If z is x plus iota y, then f of z is u plus iota v. So that means, can I write that u plus iota v is equal to f of r e the power iota theta? Yes. And marking this as 1. To get the Cauchy Riemann equations, I need to differentiate this equation partially with respect to r first, and then we need to differentiate this partially with respect to theta, right? So let's differentiate this equation partially with respect to r first. Partial derivative of u with respect to r plus iota partial derivative of v with respect to r is equal to f dash r e the power iota theta and the derivative of this with respect to r. So this is e the power iota theta. Please mark this as 2. And now differentiating this partially with respect to theta, we get partial derivative of u with respect to theta plus iota partial derivative of v with respect to theta is equal to f dash r e the power iota theta, and differentiating this with respect to theta, we get iota into r e the power iota theta. Very fine. So that is f dash r e the power iota theta, and taking e the power iota theta with this and writing here iota into r. And from 2, I can write this right hand side to be equal to this left hand side over here. So we are getting partial derivative of u with respect to r plus iota partial derivative of v with respect to r into iota r. Multiplying iota r inside. So when multiplying iota r with the first term, we get iota r partial derivative of u with respect to r. And when multiplying with the second term, we get negative of r partial derivative of v with respect to r. And here we are having the left hand side. And now equating the real and imaginary parts, we get partial derivative of u with respect to theta to be equal to minus r partial derivative of v with respect to r, and partial derivative of v with respect to theta to be equal to r partial derivative of u with respect to r. Or we can also write them as, if I need to write this first, then I write partial derivative of v with respect to r to be equal to minus 1 by r partial derivative of u with respect to theta. And from here I can write partial derivative of u with respect to r to be equal to 1 divided by r partial derivative of v with respect to theta. Whatever way you want to learn, you may learn these two equations or these two equations, that is one and the same thing. Whatever way you like, you may learn from that. So these are the polar form of Cauchy Riemann equations or CR equations. Okay, thank you. Stay blessed.